This is Frodo, and he is thinking about buying property in Sydney. But like everyone else, he is also scared of it. Is it a good time to buy a house? What if the prices drop right after he buys? And that's Sam. He comes up with a tool to help his friend make the decision. He showed Frodo how likely the house prices are to go up or down and by what amount. Are you curious to know how he did that? Let's see if we can find out what the actual probability is that house prices will decline in Sydney over the next year. Hey everyone, I'm Fariha, and today I will be explaining the tool Sam used. It's called Monte Carlo simulation. Monte Carlo simulation is a computational algorithm that uses repeated random sampling to obtain the likelihood of a range of results occurring. It was named after the Monte Carlo casino due to its reliance on random numbers and chance, similar to games like roulette. Here I have the residential property price index dataset downloaded from the Australian Bureau of Statistics website. This worksheet illustrates how prices have fluctuated every 3 months from 2003 to 2021. We can see the ups and downs. Some years prices jumped while others fell. In the filtered and cleaned dataset for Sydney, we can calculate the logarithm return for each fourth quarter price. Let's create a new column called percentage change and use this logarithm formula. I'm using the logarithm return function because it gives a more accurate result than the simple percentage return. I will just autofill with a double click. We can make a chart using the dates and log return columns. The two most important numbers we get from this history are the mean, which is about 1.29% per quarter, and the standard deviation, which is 2.69% per quarter. It tells us how much prices bounce around the mean. We will run the Monte Carlo simulation using this history to project future prices over the next 4 quarters. Think of it like weather forecasting. We examine past patterns to predict future possibilities. Now, to dive deeper into Monte Carlo simulation, imagine you are predicting your commute time to the farmer's market. A simple forecast might say 25 minutes. But a Monte Carlo simulation, however, would consider random variables such as crowd size, weather, road closures, and other distractions that might be encountered. It would simulate the commute thousands of times and produce a probability distribution like there is a 10% chance your commute is under 20 minutes, or a 70% chance it's between 20 to 35 minutes, and 20% chance it's longer than 35 minutes. This is just a fancy way of saying let's run thousands of what if scenarios with a random probability of it happening. This is far more useful for planning larger scale activities. Here I'm using geometric Brownian motion to project Sydney house price paths. The geometric nature of the model ensures that simulated prices never drop below zero, which is a fundamental property of asset prices like houses. I'm using this formula to give me a normal distribution of random returns but exponentially. The model then incorporates two key parameters, the mean and standard deviation, which are directly estimated from the cleaned dataset. The Monte Carlo simulation ran 10,000 different scenarios here based on random shock values. Watch what happens each time I refresh the sheet. This graph here shows 100 simulated Sydney house prices over 4 quarters of time. See how all the lines changed? Each colored line represents one possible future for house prices. Some go up, some go down. This shows the uncertainty. However, the more I run the simulation, a clear pattern begins to emerge based on the past prices. All the paths center around the 230 price index. Now in the percentage change column, I will use this formula to get the percentage of price changes in the fourth quarter. Here, a positive value means the has increased, negative means it decreased. So now we know how the computer uses historical patterns we saw earlier to generate realistic possibilities. The key result we actually care about is right here. This indicates the likelihood that prices will be lower over the years. Now I will count the price changes here using this count if formula on the percentage changes in the fourth quarter. This clearly shows that the price decline is less likely than the price increase. We select the category and the probability column counted in percentage to make the donut chart. Looking at it, we can say green indicates the likelihood that prices will increase, while red indicates the probability that they will decrease. This is much more useful than a simple prediction because it shows you all the possible risks, not just one misleading guess. Now that we have a grasp of Monte Carlo simulation in Excel, let's take this to the next level with Python programming. Python enables us to create more professional charts and conduct more advanced analysis in a short period of time. In this Colab notebook, we begin by loading the dataset. To verify that this matches our data from Excel file, we run basic statistical checks including a mean and standard deviation. As expected, this matched the values measured before. After that, we move on to the Monte Carlo simulation part, where we utilize the geometric Brownian model to project house prices across 4 quarters. This is the equation that governs this model. We then measure the necessary matrices such as percentage changes of simulated house prices in the fourth quarter and a list of basic statistics on those prices, like the ones we calculated before. Finally, we are ready to run this model. For better results, we can run this 10 million times and we generate some visual charts to analyze the effect of Monte Carlo simulation. Our first graph is this one. This is a distribution of simulated final house prices. The box itself represents the interquartile range, the middle 50% of likely outcomes. The line in the middle of box is the median and the whiskers extend to show the broader range of possibilities. We can make some key analysis from this. First, we have the mean and the median, both of which are above the initial price. This indicates that the simulated prices show an upward price trend, not a decline. Second, prices are likely to be between 210.8 and 251.6. We understand this by examining the 5th and the 95th percentile values. Third, from the worst case scenario, price shows a slight decrease of minus 3.6 or minus 3.7%, which isn't catastrophic enough to crash the market. The fourth and the last result is the expected growth. We observe a 5.4% average price increase. This shows the market has a bullish expectation with manageable downside risk. One other important insight we can extract using Python comes from this graph. Two graphs actually. The one on the top is a probability density function chart showing how different volatility levels affect the range of possible house price. The blue curve here is the current market volatility or the current standard deviation. The orange one introduces an additional 50% volatility. The red curve denotes the prices under double volatility at an additional 200% of the standard deviation. If we zoom in, we can see that all curves are centered around the initial price of 218.7. As volatility increases, the curves become wider and flatter from blue to orange to red. This indicates that higher volatility generates greater uncertainty and broader range of potential outcomes. The probability of a price decline increases dramatically with volatility, signaling a potential market crash. With current volatility, there is a 16.9% chance that prices will go down. With plus 50% volatility, the chance rises to 26.1%, and with double volatility, it soars up to a catastrophic 31.6%. What this means is that higher market volatility doesn't just mean prices could go higher, it actually increases the risk of price declines. The market becomes riskier in both directions. The box graph at the bottom further verifies this claim. The whiskers extend out to broader price ranges with increasing volatility in both directions. All this analysis can be summed up with these few key insights. With our starting price index of 217.8, the Monte Carlo simulation predicts a 16.9% probability of price decline, with the average final price index hovering around 230. We can claim with 90% confidence that the price index is likely to stay between 210.8 to 251.6 in the next year, mostly above our starting index. Out of 10 million simulations, only 16.9% lead to a probable price decline scenario and 83.1% to a price increase scenario. So, to circulate back to our original question, which was what is the probability of Sydney house prices dropping in the next 4 quarters, we can now confidently say that the prices are more likely to increase and not drop. We now have definite numbers assigned to this likelihood and not just some whimsical guess. The key takeaway is that this Monte Carlo simulation is not about trying to predict the exact future. It's about understanding the probabilities and all the market risk factors so Frodo and all like minded investors can make smarter decisions. These are the sources that I used for research. That's it about Monte Carlo simulation. Thank you.